Welcome to the Metroidvania Forge Chapter 5. This chapter is focused solely on creating enemies and enemy AI, along with all of the components that we'll need to make them come to life. Hi, my name is Michael. Join me as we build an epic Metroidvania game in Godot 4 using GD-Script. This is the Metroidvania Forge. Okay, well, welcome back. So it's about time we get started on Chapter 5, and we're going to be focusing on enemies, but most importantly, when it comes to enemies, is how are we going to develop the AI for these? Because there's a lot of ways that you can do this, and they range from simple, basic enemies to really advanced and emergent type systems. But obviously, the more advanced you get, the more difficult it can be to implement, okay? So what I want to do with this series is I want to implement something that kind of hits the middle ground, right? That's fairly simple and easy to maintain, but provides some kind of functionality or flexibility for us to do advanced things. So I want to talk about some of the methods that we can use, as well as some of the goals that I have for this series that I hope you also have for your game, and talk about how we can merge those two to get hopefully a good result. The obvious simple way that we could always implement something is just a basic enemy script. And what I mean by this is we just write an enemy script that has the basic information and behavior built into it, right? So like, hey, this is an enemy, and all enemies have hit points and they move and things like that. Now, this is okay. It's simple. You can extend this so that maybe you have like a slime script that extends enemy and just overrides some of the basic functionality, and you can kind of do that. But this gets kind of complicated when you have lots of enemies or drastic variation between enemies, okay? So maybe it's not always the best, but it is simple and it is extensible. Now, the next option is something that we've done a lot already because we built a state machine for our player. So we could build a finite state machine solution for our enemies that's a little bit more generic so that we can mix and match the states that we have in there. And this is nice because state machines are clean, as you've already seen, right? Once you build the state machine itself, you can just add states that meet your needs. And so it's familiar to us. So there's some good pros there. Now, some of the cons of building something like a state machine are that we might end up with kind of an explosion of states because we might have, lots of different variations of different types of states. Like what happens when the enemy's health is low? Do things change? If they're approaching the player, do they have different types of attacks based on the distance? You can imagine how this could get out of hand. But really still, I think state machines is a pretty good approach. Now, one problem that both the enemy script and the state machine have is in their decision-making capacity, because obviously our player state machine doesn't make decisions on its own for the most part, right? Those decisions come from the player, which they tell the state machine based on input on their controller. And so one way to solve that would be to build a behavior tree system. Now, a behavior tree is something where we could build a modular logic system that is able to kind of determine what the enemy should do or make the decisions for the enemy. And a behavior tree is a little bit more advanced, but pretty cool way to go. And in fact, if you want to really go hard on this, you don't even have to build your own behavior tree because there's some plugins out there that exist for Godot where you can drop them in and use the behavior tree system to start implementing your own. And so what a behavior tree does is, unlike a state machine, which says, this is what I'm currently doing, a behavior tree says, oh, this is what I want to do each frame. And it allows you to maybe add priorities and things like that. So maybe an example of how this might look is we have something like a selector piece of logic. Let me left align this real quick. And then this goes through and it says things like, if HP is low, then we do something like flee. Or if the player is in range, then we attack, right? So this is kind of a nice way. Like if you can imagine this kind of logic, but in a form that we can just drop into our scene tree for our enemy, that would be kind of cool. Now, some of the drawbacks to this might be that it's a bit more abstract, and this can be kind of hard to do. Even for me, this is not something I've built, and so while I want to build a complex behavior tree, it may not be the best fit here. Now, there's one other solution that I think gets thrown around out there, and it's G.O.A.P, which is goal-oriented Oh gosh, now I forgot it. Goal-oriented action planning. Now this is really cool. This works a little bit differently because how a G.O.A.P system works is you give the enemy goals, and instead of just deciding like if my HP is low, it says, okay, I have a goal, and maybe my goal is to attack the player, and then it can choose whichever states or whichever actions it needs to take based on that goal, right? As opposed to kind of conditions. It would be the goals. The goals could be something like, I need to get my health back up, or I need to protect myself, or I need to, if you're building it like a sandbox game, I need to chop trees to get wood. You can have goals that are kind of very different, and therefore it can lead to emergent gameplay. In fact, these G.O.A.P type systems tend to lead to gameplay systems where even the developer can't quite predict what might happen, because as you add the ability for different goals to be introduced into the game, then maybe your NPCs start doing things that are kind of cool, right? And they interact with each other better as well. But really the downside to G.O.A.P is that this would be a really hefty system to build. And we don't really need emergent gameplay either in our game, because when we're talking about a Metroidvania style game, we want our enemies to be more predictable and have behavior that is readable by the player. Okay. And so this kind of advanced AI, I don't think is going to be right for our game. Okay. So I can pretty much just decide right now that we're not going to do the G.O.A.P. Okay. But what we end up with is we've got these other three options, and really they all have some good pros and cons. And I think, the behavior tree is a bit too advanced, but at the same time, the state machine lacks the ability, like, how do we make decisions in the state machine? Do we have to build those in? Does that mean that all of our states had to have a different version for different types of enemies, right? Because if let's say you've got a flying enemy that's going to make a different decision than an enemy that's on the ground, or an enemy that has a weapon or a projectile might make different decisions on when and how to attack, our state machine could get kind of crazy with that. And so I'd like a hybrid of these two things. Okay. But what I'm going to do in this series is we're going to start with a basic enemy script. So we'll build a simple slime enemy first in this chapter, because the slime enemy, I'm going to just demonstrate maybe how some of these basic things work. Okay. And then from there, we'll move into building a more state machine-like system. But on top of that, we're going to add a decision layer, because I don't want our states to be completely in control of the decision making, because that can lead to that explosion. Rather, I'd like to keep our states as simple as we can and modular so that we can reuse them on different enemies. And then maybe it's the decision layer or the behavior layer that is different per enemy. But we're not going to go full behavior tree, because I think that's just a little bit too much for what we need. Instead, what we'll do is we'll have maybe like a decision layer node that can be overridden and extended per enemy type. Okay. And so maybe it has some basic export variables, but if you've got like a flying enemy, then maybe there's a separate flying enemy decision layer, and you can set up the states in correspondence with that. And likewise, if you've got enemies that shoot projectiles, maybe you've got like a ranged enemy decision type, okay? Things like that. So we're going to get into how we can build all of these. But one other thing that I want to talk about that's really important is we're going to make sure that whatever we build, and this is actually something that we've been doing throughout this project. So much like the state machine, we've done that before, but there's something called compositional design. And this kind of is an alternative to this extensible design. And what does that mean? So something that's extensible would be something like an area 2D, which we've extended to be an attack area, right? So an area 2D has certain innate functionalities that we use, like on body entered, on body exited, things like that, right? And what we've done here with this class, our attack area, is we're saying, well, we want everything that an area 2D does, but we're going to add our own custom functionality. So this is an example of an extensible kind of a design. Likewise, our damage area also extends from area 2D, but has a different set of custom functionalities. And so one way to approach enemies in an extensible fashion might be to build a base enemy class, and then other enemies extend from that. See, I mentioned this earlier, right? When we talked about making like the slime that extends from just an enemy. Okay, so that's one approach. Now, there are pros and cons to this. An alternative approach, and something that Godot is really designed for, is a compositional approach to this. And actually, what we've done here with the attack area and damage area is also a great example of a compositional approach. So even though these classes extend another class to get the functionality we want, the real important functionality from each of these comes by having them in the scene tree. Okay, so just by virtue of having a damage area in the scene tree, our player knows that he can take damage, and we've connected to that in our player script. Likewise, we know that this player can attack and deal damage because we've got attack areas. He also has the ability to display input hints, right? So these nodes, these custom nodes that we've built, are exactly what I'm talking about when I say compositional approach to our design. And so as we're building our enemies, we're going to rely heavily on that compositional approach because it's very modular, and it makes it so that we can abstract some of our code, and it keeps things simpler. So, our player doesn't have to worry about all the attack area important code, or the damage area, or the input hint, or even our camera 2D, right? Because all of the functionality of those is kind of pulled out and contained within its own node. So what we're going to do with our enemy is we're going to also move forward with that, because our enemies, in addition to these things here, they're going to need another layer of things like we need sensory abilities. So this is going to be things like vision cones. Maybe we need other kinds of detection areas, like an attack detection area, like is the player within range? Okay. And there could be other sensory things that we build in, right? You could have like a fake audio / distance kind of a sensory thing, or other things like that. Okay. So we're going to need to build in this sensory layer, and these are all going to be component based things, right? So if somebody needs a vision cone, you just drop it in there, and then it will work with and tie into what we're going to replace our behavior tree with. This is going to become the decision. We'll just call it a decision layer. Okay. So these are all going to be kind of integrated, and we're not going to have the G.O.A.P system, so we can turn that off. Okay. So we're going to have a decision layer, and the decision layer is going to help make decisions. And then it's going to connect to our state machine, which is going to have states. And the decision layer is going to utilize things like our sensory nodes to help make those decisions. Does that kind of make sense? And so, I've shown a couple quick examples of this as I've been talking of how this might work. And I hope that gives you an idea of kind of what we're going to be doing throughout this chapter. Okay. So again, like I said, we'll start with a simple slime. He's going to be pretty much an enemy script built in, but we will use that component style system, because we are going to use that component approach with him, though, because he will have things like a damage area, and hurt area, things like that. Okay, so he can be damaged, he can deal damage, and some other basic things that we might want to add. One thing that's sensory here that we could add, I guess, to this list that I know we're going to want is like edge detection, meaning am I on the edge of this platform? Because some enemies might not want to walk off the platform, and others might, right? And so we can add things like this edge detection to help detect that. Okay, so that's what we're going to be building. Now, this is an opportunity that I had to take to plug the enemy showcase, the enemy design showcase that I'm doing for the Metroidvania Forge series. Now, I posted a video about a week ago that introduced what this is, and the deadline is coming up on April 6th. And so I want to urge anybody who's working on that to please submit anything, even if it's not finished, because I know these things can take time. You're busy, I'm busy, and I gave a really short deadline. 2 weeks is not a long time to design an enemy. But here's the promise. If you submit something and it's an itch.io page for your enemy, and it's not 100% complete, but it gives an idea of what the enemy is, then I still want to showcase it, and I still want to talk about it. And if that enemy is cool and the community loves it, and you're able to get the animations in that are needed in time, then I can still include it later down the road, because I'm not going to be recording all of these videos on April 6th, right? This is just me giving a deadline so that you and I have a way to hold ourselves accountable and get something done. Okay. So submit something, and hopefully it's awesome, and we'll talk about it, and I'll give feedback, and maybe that'll even help you, finish it or fix issues that you were struggling with as you're designing your enemy. And then what I'll be doing in the meantime is I'm going to be building this basic slime enemy, because I've already got an asset that we can use for that. And so I'm going to put that out there, and I'm going to get started here on chapter 5. So thank you for watching. Thank you for tuning in. I hope you guys are excited for this chapter with enemies. It's going to be a little bit different. I'm not going to be able to approach it like I've done in the past, where once I have my plan, I just knock it out. I'm as I do this slime, that's kind of stage 1. Stage 2, I'm going to be developing out, because I still have to finish my approach for the finite state machine and the decision layer. Okay, so I'm going to be working out some of the kinks I've got with that right now. And in the meantime, I'm hoping you guys provide some cool enemies that will give me ideas. And you know, whatever enemies we design will kind of dictate some of the modules and some of the custom nodes that we build to make these state machines or the decisions or, you know, the sensory things. All of that, all of the things we build there are going to kind of emerge from the types of enemies that we're creating. I hope that this video was valuable in kind of giving you a roadmap or showing you how I'm making some of these decisions. And I also hope that you're having fun designing some enemies if you like making pixel art. So thanks again for watching. I've been rambling. Go ahead and give this video a like if you're excited for what's coming. And if you're new, then obviously subscribe so you can see the next video. And as always, we'll see you next time.